Okay, this is the P1 paper from June 2021. It's question number 5. It's actually a quadratics question with a bit of quadratic graphs and inequalities. It doesn't look like a quadratic, so let's just have a proper look at this. You might want to pause the video. We do have a link to the paper in the description, so you might want to just have this one out looking at the whole of the question while I go through and do different parts to it. But basically what we're saying is that this is a modelled share values of two different companies, company A and company B here. We can see that company A is that one, is this quadratic, and company B is this one, which is a linear function. And then they're going to ask us questions about what happens to the various different things over a 15-year period. That's important right at the very end, but that basically this is t equals 15 years just at this point here. Right, let's get started with it. So what does it say? First part, it says, find the difference between the share value of company A and the share value of company B at the point monitoring began. So it wants to know the difference between those two values there, which is dead straightforward in terms of the algebra. Let's just show what we're going to do then. So for part A, I'm going to work out PA at t equals 0. So PA is 53 minus 0.4 lots of t minus 8 squared, or in other words, 53 minus 0.4 lots of minus 8 squared at t equals 0. And if you calculate that, it comes to 27.4 million. Let's do the same for PB. So PB at t equals 0 as well. So PB is given by minus 1.6t plus 44.2. So at t equals 0, that's going to be 0 plus 44.2. So that's going to be 44.2 million. And what we want, what the question says, is the difference. So difference is simply equal to 44.2 minus 27.4, which works out to be 16.8 million. Okay, so that's part A. That difference there is 16.8 million. Okay, part B. Part B says, state the maximum share value of company A during the 15-year period. So we want this maximum value up here, and that is just relying on the fact that I've already got PA written as a completed square. So part B, PA is given by 53 minus 0.4 lots of t minus 8 squared. So here they haven't actually made me complete the square, but they had made me do some work on understanding what completing the square does. The whole point, just really, really quickly, is that if I've got this completed square here, 53 minus something there, and the something is squared, so the maximum value I can have for P is when that's as small as possible, and the smallest thing that can be is just 0 in this case. Classic completing the square work. At t equals 8, this bit will be equal to 0. So at t equals 8, PA is equal to 53 minus nothing is just equal to 53 million. Only worth 1 mark because it's a really, really standard thing to do in terms of completing the square questions. What does part C say? Part C says, find, using algebra and showing you working out, the times during the 15-year period where the share company of A is greater than the share company of B. So if we're looking at this graph again, what they're really saying is, can we find what T is when they meet there? anything greater than that, the value of A stays above the value of B. So what I'm going to do, my game plan is work out PA equals PB, and when I find that time there, it'll be T greater than 1 year, 2 years, whatever the answer is going to be there. We can see from the model that in the time period of 15 years here, PA will always stay bigger than PB. So I don't need to worry about an upper limit. It's just going to be whatever that lower limit's going to be. Okay, so my game plan is to make them equal to each other. So find when PA equals PB. Always good to tell the examiner what we're doing here. So we've got 53 minus 0.4 t minus 8 squared is going to be equal to 1.6t plus 44.2. So I can see, before I get started with this is all going to work out to be some sort of quadratic. If they were really clever with the question, it might be that it factorizes in some way. If I can't make it factorize really easily, then I'll just use a quadratic formula for it. So I'm not going to do too much with this. You should be able to do all of this work. It's just about making sure you don't make any silly mistakes here. T minus 8 all squared. You can do it slowly if you want. T minus 8 times T minus 8. But I'm going to do it slightly quicker in my head here. It's T squared. It's minus 8T minus another 8T. So that's minus 16T plus 64. By all means, you take your time and do that slowly. Let's get everything over to one side and equals 0. I'm probably going to take everything over to that side and end up with 0.4 t squared. So I will do 0.4 t squared. I'm going to end up with 0.4 times 16t, and then the 1.6t. If you combine both of those, that makes minus 8t, and the constant, I'm going through this quite quickly, just in terms of not making the video too long, should come out to be equal to that as my quadratic. Now I could, as I say, I could multiply it all out and try and tidy it up and factorize it, but I think the quickest thing to do is to just use a formula in this case. I'm going to say t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's just get these values. So t works out to be 8 plus or minus the square root of b squared, so that's minus 8 squared, minus 4 times 0.4 times 84 over 5, all over 2a, so all over 0.8. And I'm just going to jump straight to the answers. The answers are 10 minus root 58, and I think the other one's 10 plus root 58, but I'm not bothered about the bigger of those two values. That's going to give me t equals 2.38. I think the other one works out to be t equals 17.6 or something like that, but let's go back to what we were saying just a minute ago. Yeah, eventually they would possibly meet down there somewhere, but that's outside my remit. I do not need to worry about this upper value here. So I'm not interested in that one. I'm not going to underline it. I'm not interested in that one there. I'm interested in t being equal to 2.38. And in answer to our question, if t is greater than 2.38 at that point there onwards, then we get that PA is greater than PB. Just check the question. No, it doesn't say anything about decimal places or significant figures, so I can just do that. And then part D. Part D says, explain why the model for company A should not be used to predict its share value when t equals 20. Which is a little hint for any time you're doing these models. Always look when time gets really big. What happens? Models will collapse when time gets really big a lot of the time. So here, if t equals 20, it's only worth 1 mark. So there's nothing to stop you just saying share is going to become negative, but I'm actually going to make sure I want to get all my marks here. So PA at t equals 20 would give me P 20 is 53 minus 0.4 lots of, well, it's going to be 12 squared if I put 2 equals 20 in. That works out to be minus 4.6. We cannot have a negative share value. Okay, hopefully that makes sense.